Also joining us is Vipul Mishra. Vipul is a blockchain developer with deep expertise in both public and private blockchain networks. Vipul has built and deployed multiple Web3 projects, including NFT marketplaces, DeFi contracts, and crypto trading bots. He's worked extensively with Ethereum, Hyperledger Fabric, and smart contracts, and he has led teams both as developer and CTO, Chief Technology Officer. Vipul holds a PGP in software engineering with a focus on blockchain from Triple I. Also joining us is Vipul Mishra, Bangalore, and brings hands-on experience in building real-world blockchain solutions. We are excited to learn from his journey and practical insights into the future of blockchain. So, very warm welcome, Vipul. Over to you. Very excited to have you, and the floor is all yours.
Sure. Thank you so much, Devesh. Thank you for the warm introduction. We will be starting the class about the blockchain basics. This is our first class. So we'll be discussing the basically the overview about the terminologies and the topics which are initially discovered and invented through the practices and then implemented by the people in subsequent years. So quickly, we will be going through the content that has been created by our course director, Dr. Swarup Reddy, introducing the blockchain. So it basically is a combination of a few things, right? And we'll start with the ledger. A ledger, in a simple word, is a record book. Now, let's suppose we have a few transactions going on uh, between two people or maybe between two organizations, and we are basically storing it in a sequential manner, right? So it basically is called a record book. So you will have a record book, and you should see it earlier and back in the days, like the shopkeepers used to maintain the record book if somebody is purchasing stuff from there, so that they will have a record or a track of the things that they have purchased and the amount that they have paid, and what date and what time they have been making the transactions, right? So a ledger is simply a record book. Now, when we take a ledger and we basically associate timestamp with it, and we try to make sure that this is stored digitally, it basically becomes important that we can use it in a bigger picture. And there have been technologies, there have been concepts which have been introduced in order to make sure that these digital transactions can use widely in different industries, and in order to make the digital transactions more transparent, more secure, and more accessible to people from different regions of the world, right? And blockchain technology in itself was a big step forward in order to enable that kind of work, or that kind of technology to be taken over through the different areas of the work, right? So when we go with the definition of the blockchain, it is basically a distributed immutable ledger. When we say it is distributed, it means that it allows the not the centralized nature of any transaction. It allows the transactions to be stored on different peer as in different people who are activated in a particular network. We will be talking about that in a while, in a more detail. So immutable ledger means a ledger which cannot be changed once it is deployed. So this is again a property of blockchain technology, where once you have a transactions, once you have a block where you have multiple transactions, once it has been mined, it means it has been posted on the blockchain. It cannot be changed. No transaction can be tampered from that, right? So it basically like brings the concept of security into the blockchain technology. Now, as I said, this is used to help record transaction in a secure, verifiable, and transparent manner. It is secure because it cannot be tampered. Nobody can change any detail on a blockchain network once it has been put there already. It can be verified through the public interfaces that has been created by many developers in order to go and look at the transaction. Now, people can always go and look into the transaction who has the coding experiences and can actually have their network set up accordingly. But for the easier access of general public, they have been interfaces created, websites with interfaces created, so that the transaction can easily be accessed. For that example, if you want to go ahead and check the transactions happening on Ethereum, there's a website called ETH Scan, and there are hundreds of these kind of different website where you can go and check these transactions. Now, the transactions are again transparent because these can be checked, and as you look at these websites and you are able to look at these transactions happening every second, you can always see what is going on the network, what is the amount of currencies that is being traded, what are the smart contracts that is being implemented and the functions of the smart contracts. So we will be talking about these smart contracts and regular cryptocurrency as well. So there are some key concepts in the blockchain. So as we talk about, the first thing is distributed database. So database again is something similar to ledger. A ledger, as I said, is a record book. A database is something which is storing the data on a digital device, on a digital hardware. Now in case of a regular database, the data is actually stored only with a central authority, and we'll actually talk about some examples, and we'll then discuss how it is different from the blockchain, right? And what new concepts the blockchain has brought into the traditional on top of the traditional databases. So when we talk about a regular company, a private company, you know that they have their own database. So any company data, any customer base data that they have, they will be storing it in their in-house database, or they will have some cloud ID where they will be saving these data, right? Now this data is only accessible by the company management or whoever they allowed it to, and mostly it is the people or the employee of the company itself. It is obviously not publicly accessible. Now, this data is also stored on limited number of devices. Sometimes it is only stored on a single server, and it basically has a risk. So if it is stored on a single server and the server goes down, you will not have access to the data, right? So this is the traditional form of database that we have. We store it on a single device. It is risky, but it is very efficient. You wouldn't have to go look around in multiple servers to get the data. Now, on top of this, we can get the example, we can go with the example of an airport for that matter. And at an airport, we will have I'm sorry, it is a distributed database at the airport as well. However, it is not distributed among a lot of devices. So, you know that there are different departments for the databases that they have. They do not keep it on a single server. They do have multiple server to make sure that if there's a single point of failure, and if a server goes down, the data can be fetched from the other databases. Now it is still actually centrally authorized. There's only one central authority keeping the permissions, keeping the authority over the data and the database, and that is, in this case, in this example, is an airport. The data cannot be actually fetched and seen by the general public, and they have the complete control over the data. Now let's suppose you have a certain data set in your database today, and tomorrow some company asks you for that data. You can always change the data in that database, because the only people who are taking the authority over that database is the airport people, right? The people who have the stakes in it. So we went through the example of a traditional database when mostly there's only a single point of failure, and there's only one authority. We then speak about the example of airport, where the data is actually distributed among multiple servers but still has one central authority. Now on top of that, we have something which means that the data can be distributed, and it will also not have any central authority keeping the permissions in order to change the data once it is being out in the public. And this is something which has been possible by using the blockchain. So blockchain allows us for a distributed decentralized database. A distributed decentralized database, just by the name of it, you can understand that the database will be distributed. It will be available among multiple set of people. On top of the bonus point is that these people does not know each other. We will talk about how this whole entire network thing works when we will be talking about the consensus mechanism. But the core feature, the main principle of a blockchain technology is that it allows the decentralized nature and the distributed nature of the data being saved on the servers, right? Now, we can talk about the second key concept here. It's cryptographic hash chaining. Now, as I spoke about the ledger initially, right? The data is stored on a ledger, and we will just keep the discussions on from there about in a sequence about how it is made possible into a complete concept of a blockchain, right? So initially, we will have a record book. We will have a ledger where we basically save the transaction which happens on a regular basis, and it will be saved in a sequence with the timestamp. So it means it will have the time with it when it was executed. Now, once we have a ledger, we also call it the pool of transactions. So the ledger will then be hashed, and the hashing is a concept which is very famous for anybody into the computer science domain knows how important hashing is. Hashing is basically a kind of concept where you take certain data and you let it go through an algorithm, and you basically get a long sort of string or long sort of proof. Now this proof basically have we can actually create a long string. I believe you know what a string is. It's basically a combination of uh, a lot of uh, these alphabets and numbers, and we do have some certain standardization or the regulation around these as well. So once you take a set of transactions and that you have saved in a ledger and you let it go through these hashing algorithms, it basically gives you a long set of numbers and alphabets, which we call the hash. And this hash acts as a proof about that transaction. And I'll tell you how it acts as a proof. Now, let's say you have five different transactions in a ledger, and somebody comes out and tries to change even a single detail about those transactions. Let's say we have five transactions, and somebody comes and change a number in the second transaction. Any change in the transactions of a ledger would basically trigger the change in the hash. And as soon as we know that the hash is changed, the long string of numbers and alphabets is changed, we know that there is some addition or there's some changes that has been made to one of these transactions. And it makes it very easy for the people who are basically trying to verify or validate these transactions to understand that there have been some changes. And since blockchain introduces uh, hashing as one of its key component, and it makes it very easy for us to make sure that the data is not tampered, right? So once you have a hash, you can use that hash as an identification of a particular block. Now, by talking about the block, we'll say that a block is basically a simple storage of data, timestamp, and the hash of that data. So these three things are generally stored on a block. We do have different blocks in different sort of consensus mechanism in different sort of blockchains. We will be talking about the differences among those. But in general, for now, you can understand that the block contains the data and the hash of the data and the timestamp of that block when that block is mined. We will again be talking about the mining and how a blockchain is mined when we will be talking about the consensus mechanism, right? Now, for example, again, we can see that Bitcoin is a blockchain used for the peer-to-peer digital cash. So, blockchain is actually one of the first implemented blockchain example that we have. It was initially introduced by Satoshi Nakamoto in the year of 2008. He's a very famous personality for the people having interest in cryptocurrencies. They know that this is something that was created, and then the person who created it just disappeared. Nobody knows who he is and where he's from, and he never came in front. Right, he never showed up. So what he did is that he actually took a few different concepts, and he joined those concepts to basically made a very much future proof technology, and that we in today's days know as Bitcoin. Now Bitcoin is basically a blockchain that we have introduced by Satoshi, but we also have a cryptocurrency that is known as Bitcoin. So we'll not confuse while we will be talking about the language of the Bitcoin technology and also the currency that we use. So when we say Bitcoin, it means that we are talking about the currency, and when we talk about the Bitcoin blockchain, we'll just say Bitcoin technology here. So Bitcoin technology has some of its own key features. It has its own consensus mechanism. Now, I'll introduce what consensus mechanism to all of you guys, what exactly it is. So, as I was speaking about the ledger initially, we have a ledger where we have a store of data, and then we hash the ledger, and we have a long string of numbers and alphabet that acts as a proof of those transactions. If there's any change in that transaction, the hash will also change. So we have the hash, we have the data, and we have the timestamp of that, and we store it on a block, right? And once a block is posted, it becomes permanent. Now, when we talk about a block being posted, it can also be said as block being mined. Mining basically means that all the transactions that is going to be on a block is verified. It is made into a pool where we can actually make a sequence of these transactions according to their timestamps, and then we basically have its hash, and then we create these transaction pool, and then we push it to the blockchain where we have the previous block, and we push the new block to the previous block, right? The whole procedure of validating, verifying these transactions and then who exactly is going to post or mine this block on the already existing blockchain technology. The whole procedure is known as consensus mechanism. Now, why exactly is it called consensus mechanism? Is because, as we know, we will take the example of public blockchain networks here. We have a lot of people who are part of the blockchain network who actively participate in order to make sure that they have these data stored on their personal digital hardwares, and then they are also validating these transactions every time, right? And the reason why they do it is because they do get the reward fees as they validate a transaction. Now, how and who will be validating a particular transaction in a group of network? Because you should know that there are millions of people who act as a validator, who come join the network as the validators on a particular blockchain network. And there are, of course, the rules defined according to the consensus mechanism, because there are multiple consensus mechanism depending on the use and the practicality of any particular blockchain. So we make a certain rule about how and who can validate a transaction and then put it on a block, right? And among multiple people, whether it is a group of people who's able to validate a transaction, or whether there's just an individual who's able to validate a transaction then put it on a block, they are then rewarded with a fee. In case of Bitcoin technology, they are rewarded with the Bitcoin cryptocurrency as a fee. In case of Ethereum, they're rewarded with the currency which is associated with that particular blockchain. So in Ethereum, they will be rewarded with the Ethereum currency. So that is the consensus mechanism and how the validation and verification happens on a blockchain network, right?